Welcome to Ask and Learn.
Okay, so we're doing chapter 9, problem 5 here. So we have it says a 145 gram baseball is moving along the x-axis with a speed of 30 meters per second. Okay, so we have here along the x-axis, it's at 30 meters per second, and it strikes a fence that's at a 45-degree angle, like this. Such that this is 45 degrees, and rebounds along the y-axis straight up here. Cool. It says give its change in momentum using vector notation. Okay. Well, we know that momentum. Well, we can take the change in momentum as mass times the velocity, and if the mass of our ball is the same, which it is, we can write this as mass times the change in velocity. So this now just becomes mass times the final velocity minus the initial velocity. Okay, well, we know the magnitude of velocity doesn't change. It says unchanged speed. So we can pull that out such we have the magnitude of the initial starting velocity. And now this is equal to the final unit vector minus the initial unit vector. And this is easy. These unit vectors are nice because it's incoming along the x-axis and the outgoing velocity is all along the y-axis. So if the final is on the y-axis, this becomes n times the magnitude of the initial speed. And the final is on the positive y-axis, that's j. And the initial is on the positive x-axis, so we subtract an I hat. Cool. So now we can just plug this in, and we should see if we want to keep things in SI units, we can use a mass of 0.14. Oops, got the 145 kilograms times the speed, which is 30 meters per second. And then we have our direction here, j minus I. So if we plug all that in, we get a change in momentum of 4.35 kilogram meters per second, and this is in the j minus I directions. Cool.